Hey, what's up, Mr. Sutter here. Today we're going to be talking about velocity and acceleration. So velocity is just speed in a given direction. Velocity has two components, a direction and a magnitude. In this case, our magnitude is speed. So if you have a direction and a speed, you have a velocity. So let's take an example here. So subway conductors are only concerned with speed. The subway runs on a track, although you can change tracks. Usually the subway runs in a loop, so the train is either moving with a speed or not moving. The subway conductor isn't really making changes in direction. However, pilots are concerned with velocity. They have to know the direction and the speed. So for example, we have this plane and we're traveling 300 kilometers per hour to the west. So our velocity is 300 kilometers per hour west. Now this is very important. So let's say I'm in New York and I want to go to California. If I'm in New York and I want to go to California, sure, 300 kilometers per hour west is a perfect velocity. However, if the pilot only knew they had to travel at 300 kilometers per hour, they may travel east by accident. But if you traveled 300 kilometers per hour east by accident, you would end up in London instead of California. All right, so when a car moves faster and faster, its speed is increasing. We call that acceleration. So, did the velocity change as the car continued to move faster and faster? And of course, velocity is the same as speed with a direction. So as the speed increases, the velocity has to increase too. When a car moves slower and slower, its speed is decreasing. We call that deceleration. Did the velocity change as the car continued to move slower and slower? Yes. Again, velocity is the same as speed, but with direction. So as speed decreases, velocity has to decrease as well. One more hypothetical here. When a car changes direction, does the velocity change? Yes, the velocity is the same as the speed again, but with the direction. So if the direction changes, the velocity changes too. So if I'm traveling in a car at 60 miles per hour and I turn my car to the right and I keep my foot on the gas, if I'm traveling north at 60 kilometers per hour, and then I make a right turn and I'm traveling east at 60 kilometers per hour, my speed stayed the same. However, my velocity changes because I change directions. So if you change directions, you change your velocity, right? Acceleration measures the change in velocity. Again, velocity being the direction and the speed. Acceleration is equal to change in velocity per unit of time. And we can rewrite that. Uh, this little triangle here is a delta symbol. Delta means change. So acceleration is a change in velocity per unit of time. And we can rewrite that as acceleration is equal to my final velocity minus my starting velocity. This will be my change, my starting minus my final minus my starting, divided by the total time taken. My unit for acceleration is meters per second, or we can rewrite that as meters per second squared. So our units for acceleration are meters per second squared. So how do we know that the units for acceleration are meters per second squared? So again, I'll start with my formula. Acceleration is equal to my final velocity minus my starting velocity divided by the total time taken. So here's acceleration. Velocity is measured in meters per second divided by the total time taken, which is time is measured in seconds. So it's meters per second divided by seconds. But really, we can flip it over. So it's meters per second divided by seconds. So this is a fraction divided by like a whole number. So in order to divide a fraction by a whole number, you have to cross multiply. So I have meters per second times, in order to multiply a whole number, I have to get the reciprocal. So I flip it over. So it's 1 over seconds. And I multiply straight across. Meters times 1 is meters. Seconds times seconds is seconds squared. And then again, I can rewrite that as meters per second squared to make it a little bit more readable, I guess. All right, let's look at an example here. So the Ferrari 348 can go from rest, 0 meters per second, to 27 meters per second, about 60 miles per hour, in 5.6 seconds. Super fast. So what is the acceleration of the car during that time? So again, acceleration is equal to my change in velocity over time. So we have my final velocity minus my starting velocity divided by the total time taken is equal to the acceleration. So let's make our substitutions here. The final velocity of the car, 27 meters per second, minus the starting velocity of the car, which was 0 meters per second, it was at rest, divided by the total time, 5.6 seconds. So the acceleration of the car as it went from rest to 27 meters per second was 4.8 meters per second squared. Question for thought here, right? So a running student is slowing down in front of a teacher. She's probably telling him to stop running in the hallway. Is the velocity of the student as they're slowing down in front of the teacher positive or negative? Now my velocity here is still going to be positive because as the teacher is running towards the student, they're moving to the right, they're slowing down, but they still are moving towards the teacher. So they're just moving slower in that direction. So the velocity changes, but because they're still moving towards the teacher, their velocity is positive. Now, is the acceleration of the student as they're slowing down positive or negative? Now, the acceleration of the student here is going to be negative because although they're still moving towards the teacher, they're trying to slow down. So they're trying to lose speed, and when you decrease your velocity, that's called deceleration. So that's a negative acceleration there. The acceleration is in the other direction. One last example here. All right, so in 2.5 seconds, a car speeds up from 60 kilometers per hour to 65 kilometers per hour, while a bicycle goes from rest to 5 kilometers per hour. I want to know which one has the greater acceleration, right? Acceleration, again, is the change in velocity per unit of time. So let's do our formula here. So the car went from 60 kilometers per hour at starting to 65 kilometers per hour. So 65 minus 60 is a change in 5 kilometers per hour. 5 kilometers per hour divided by 2.5 seconds is equal to 2 meters per second squared. So the acceleration of the car is 2 meters per second squared. What about the bike, though? Right, so the bike went from 0 kilometers per hour rest to 5 kilometers per hour. So 5 minus 0 is a change of 5 kilometers per hour divided by the time, 2.5 seconds, and we get 2 meters per second squared. So my car and my bike have the same acceleration. So although the car is moving much faster than the bike is, because their change in velocity in that same amount of time is the same, therefore my acceleration also has to be the same, right? That's going to wrap it up for velocity and acceleration. Thanks for watching. I hope you learned something, and I'll see you in the next video.